Hello everyone. Today we are going to discuss about the different machine learning phases and maybe split it into three separate videos. In the first one we are going to discuss about the data transformation, feature engineering and others. The second we are going to see how once we have fine-tuned the data we can do a train on the model and create a model, and finally how do you expose it as an API. Okay. So today's video, let's learn about EDA. And the sample dataset we are going to look at today is the diabetics dataset, which has different blood tests and body parameters of different people. And finally, we have a target which says either diabetic or not. So it's a binary classification. And so let's start with exploring the data. First step is to load the data set. So we are using pandas to load the data set. So if you see the data set itself, maybe initially itself we are just printing the head, which returns around 5 records. We can make a lot of inferences out of it. For example, we have a serial number data which ideally we don't need for the training, and then there are a lot of NANs. Finally our target, which is zeros and ones. Okay, so the data looks good. Let's first print the info. So info is an interesting pandas method which gives us the total number of entries of record and also the total columns in it. Also, more importantly, there are two datas here. One is, do you have any missing values? So out of 921 in the breakfast blood sugar test, we only have 132 entries. Similarly, we also can use it to understand the type of the data. So the integers and the floats are the good ones, in the sense you can directly feed it to the machine learning model. But the objects we have to understand more and try to convert it into integer or float, right? So the first step we could easily do is, as we discussed, serial number is just numbers which we could remove. So that's how we are dropping serial number first. Then we are trying to use the describe method, which gives us a statistical overview of the data. So the number of counts, the mean value, the deviation and others. So the one thing to note here is this only works with integer and float values. So even if this object values could be internally integer or float, we are not able to plot that. Next, like we saw previously, there was NAN. We want to make sure there are no other, I would say, non-numerical values, right? Like jargon values. So we can print all the values which are not numeric. And here you can see there is a null, weird string null value, as well as NAN. NAN is okay, but this one we will have to fix it. And the easiest way is to go around and replace everything with NAN, right? So that we have completed. The next step would be, again we are trying to see the info, how the things look now. And if you see, there could be few more columns which has now null values, right? So let's try to print all the columns which has null values here. So all these columns have null values. Again, this is a decision you have to take based on the data set and your expertise, whether to continue to use this columns, or should we do any transformation and all those. That's where the EDA step comes, because once you give this data to the model, it's going to learn from the data, right? So that's why this stage is really important. So one thing which we see here is interesting is all of this only have one value, which is null. So maybe it's easy if it is a single row, maybe we could even drop that. So another thing which we do is try to print the correlation between all the columns. Okay, and here we are using matplot to plot the correlation graph. Okay, so this is the correlation matrix, and the main thing to notice, the diagonally it will be 1:1 correlation because you're comparing age to age, right? That is expected, and whichever is on the higher sides, there's a good correlation. So in our case, we are trying to compare it with the target, right? So target, a lot of these fields have good correlation with target, so it's a good data set to train your model on. However, one thing you will notice is that this fasting BS2 T as well as fasting BST have one correlation, which means they are exactly duplicate values in both these columns, and we could drop them. That's exactly what we are doing next. Then yeah, we are trying to see that one row where it was all null, right? I mean this one, we are just seeing whether height and weight also in that is also null. So in that case, the easiest step to do is to replace that, right? So if you can see here, yes, all of these are NaN, right? So that one row, I believe we could drop it. It won't make any big impact on our data, right? So we are dropping that, and here we are converting these values back to float. So if you try to do an info here, df.info, yeah, df.info. So now we have seen the number of rows has reduced by 1, and all of this which were objects have now converted to float, right? So that's a good thing. Okay, now going forward, let's now see what all are still null. So these many of these are still null, and we have to decide what to do with them. So now imagine you have good understanding about the data, and here I'm not an expert, but some of this data set like the waist hip ratio can be replaced with values from other columns, right? So for example, the hip ratio or the waist ratio, they could have a correlation with the BMI, right? So what we are doing here is go to the BMI column, find any value which is equal, the BMI values you're finding, right? And we're taking a BMI value, let's say the BMI value is 20, and for this row where hip and waist circumference are null, if the BMI is 20, we're going to replace that value there, right? So we are trying to fill the null values with values where it is similar to the people who are in the data set. There are other ways of filling also, like by the mean and average values, but this is more related, you could say, right? So rather than saying find the average waist and use it, we are trying to find the same type of person who has the same BMI and trying to replace it. Okay, great. So here we have transformed that. Then finally we come to these two values, right? Where this oral glucose is 600 and, breakfast is 132 entries only. So those things, I don't think we can do much transformation, right? So for now we are just filling them with the mean values. Okay. So finally we have our data set which has 920 records, and all of them are non-null now, and none of them are of the type object. That's the basic type of EDA people usually do to convert their data and make it meaningful for the model to learn. Um, Again, one another thing which is interesting is we have done the EDA manually by going through the data. There are libraries which allow us to do automatic EDA. So one such library is called Sweetviz. So let me try to show this. If you run this library with our data set, it's going to read the data, and it is itself going to plot all the correlations and other maps, so that we can understand how the data is without doing a few of this manual EDAs. However, you have to do the transformation yourself. Like once you identify that the data has been there is null and other values, you have to decide the logic to convert it. Okay. So here we are trying to load the data, and once this library completes, it's going to create an HTML page. I'll quickly try to show that too. So it's trying to go through all the data and find the details. And the Sweetviz is just one of those libraries. There are different other libraries which give us the same functionality. Okay. So the report came in a different, let me pull it up here. So if we can see here, it has a detail about what are the values of each column, and even it has values whether there is a missing value. Like here it has highlighted 14% are missing, and it even plots a graph on how the data looks. So this could be a very good first step of your EDA to understand more about the data, and then decide on what transform. Even it prints a heat map too. Okay. Thank you everyone, and hope to see you in the next video where we try to build a model with this data set. Bye bye.